Hello everyone. In this video, let's take a look at two main methods for investigating limits. The two main ways we do this are by making a table of values or by taking a look at the graph of our function. So let's start with a table of values as a method to find the limit of a function. So let's start with an example. Let's say that we have a function f of x, and let's say this is equal to x squared, so our quadratic function. And now let's say we want to find the limit of our function f of x as x approaches, let's say, the value of 2. And we want to find out what this is equal to. So we can do that with a table of values. So let's create the table. So we have a column for x, and then we have f of x. And in the middle, we want to figure out our limit at 2. Now this is a continuous function, so we could plug this value in, but what we want to do to find our limit is we want to pick out values of x that are getting closer and closer to this value of 2. So maybe we'll pick out the value of 1.9. We can pick out a value a little bit closer. We can do 1.99. And maybe we'll get even a little bit closer and do 1.999. So this is our left-sided limit. So this is the limit as x approaches 2 from the left. And then we also want to do values of x from the other side as well. So maybe we can do the value of 2.1. We can get a little bit closer to 2, and we can do 2.01, and maybe we'll get even a little bit closer and do 2.001. So now we're approaching the value of 2 from the right-hand side. So this is the limit as x approaches 2 from the right. And what we want to do now is evaluate our function for these. So let's plug these into the calculator and see what we end up with. So we're squaring these values. So if we do 1.9 squared, we get 3.61. And we can do 1.99 squared, and we get 3.96 about. And to finish up our left-hand side, 1.999 squared. And that's going to give us roughly 3.996. So as we're plugging in values for x, as they're getting closer and closer to 2, it looks like our values for f of x are getting closer and closer to 4. Let's do our right-hand side now. So 2.1 squared, we end up with 4.41. Our next one, if we do 2.01 squared, we're at about 4.04. And our last value, 2.001 squared, we get a value of about 4.004. So again, just like the left-hand side, on the right-hand side, as we're plugging in values for x that are getting closer and closer to 2, it appears that the values for f of x are getting closer and closer to 4. So because coming from the left-hand side and from the right-hand side, we appear to be approaching the same number, the limit of our function as x approaches 2 is equal to 4. So just using a table of values, we can find the limit just by picking out values of x that are getting closer and closer, that are getting really close to our value for c from both sides. Okay, the second way we can investigate limits is by looking at their graphs. So I have two different interesting functions here, and I want to investigate some of the limits. So the first one, g of x, this is equal to 2 times the sine of x divided by x. And why don't we take a look at the limit of our function, so the limit of g of x, and let's find out what our limit is as x approaches 0. And what is that equal to? So what we're going to look at on our graph is we need to look both ways. So as our x values are getting closer to 0 from the left-hand side, we need to take a look at what's happening to our graph this way. And we also need to do the same thing from the right-hand side. So as these x values are getting closer and closer to 0 from the right, what is our graph doing this way? For the limit to exist, the left-hand side and the right-hand side, they have to be approaching the same point. And in this case, it does look like they are. So as we move our x values closer to 0 from the left, it seems that our graph is getting closer and closer to this y value of 2. And as we move our x values closer to 0 from the right-hand side, it looks like our graph is also approaching this y value of 2. So that means that our limit as x approaches 0 is equal to 2. And now let's do the same thing for our second graph. So let's take a look at the limit of h of x, which is the function 1 over x, our reciprocal function. And then let's take a look at what we end up with as we approach 0. And what is this equal to? So same idea. We need to take a look as our x values are getting closer and closer to 0 from the left, what's happening to our graph. In this case, our graph is falling very quickly, and we're actually shooting down to negative infinity. And then what's happening as our x values are getting closer and closer to 0 from the right-hand side, our graph, coming from this way, our graph is shooting upwards, and it's actually approaching positive infinity. So because our left-hand and our right-handed side limits are approaching different values, in this case, the limit doesn't exist. So the limit doesn't exist. So those are the two main methods we can use to investigate limits. We can create a table of values and pick out values for x that are really, really close to our value of c. Or we can take a look at the graph. As our graph moves along from the left-hand side and the right-hand side, as we approach that value, we can take a look and see what's happening to our y values. Thanks.